Okay, this is physics under current electricity. We are solving example. This example is from the past question 1979. So, given the circuit diagram here, we are told that if the ammeter reads 50 milliamps, that we should calculate R. R here represents the internal resistance of this cell. So 1 ohms here represent the internal resistance of this other cell. There are two cells, cell P and cell Q. Cell P has EMF of 1.5 volts. Cell Q has EMF 2.0 volt. Here we have our external resistance, which is 7 ohms. So we should calculate what? R. So let's get it done with. So being to the fact, now we are going to simplify this cell here. We are going to simplify this cell here, but you know that when cells are in series, for series cells, the equivalent EMF for series cells is equal to what? E1 plus E2 plus dot 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 what? En, wherever it stops. So here we are going to add the first cell to the second cell. However, you don't just begin to do the addition like that. You have to take cognizance of the signs of the cell, or let's say the polarity of the cell. For the cell P here, the polarity here, we have positive, negative. This is the positive terminal and this is the negative. But you come here to the cell Q, we have negative first before positive. So what does that tell us? That the they are in opposite direction. While P is trying to supply current to the left side, Q, instead of supporting P to the left, is trying to support to the right side. So since they are not in same polarity, we will subtract them. And when we do the subtraction, the current will now move in direction of the cell that has the greater voltage or the advantage there. So our equivalent resistance will be 1.5. Did I say equivalent resistance? Equivalent EMF or voltage will be 1.5 plus, since this one is in opposite direction to this, we add negative to that, negative what? 2.0. And that will give us, if you do that calculation, that will give us minus 0.5 volts. Minus 0.5 volts. The minus here means that with respect to P, that the current will not flow to the left, that it will flow to the right, because Q is greater than P. So bearing that in mind, I'm going to redraw this circuit here. I'm going to redraw this circuit. So combining, so we are now going to have only one cell here on the right direction. Only have one cell there on the right direction. And what will be the voltage or EMF of that cell? That's equivalent EMF. It will be what? 0.5 on this other direction. And what will be the internal resistance? Then you can recall that for internal resistance, me clean that up. You can recall for internal resistance, when they are connected in series, the equivalent resistance will be what? R1 plus R2. And our R1 there, we remember, was what? R. So we write R. And the internal resistance of the second cell was what? 1. So the equivalent internal resistance will be what? R plus 1 ohms. Will be R plus 1 ohms. So let's move that up. So coming back to the formula to analyze a circuit having EMF and internal resistance. EMF E equals to what? EMF E equals to the current through the circuit times what? External resistance plus what? Internal resistance. But this time around, internal resistance will be the equivalent of the two cells. So our external EMF we calculated was 0.5. Our current is 50 milliamps. Our current was what? 50 milliamps, and is not in its standard unit. 50 milliamps, convert that to amps. Milli means 10 raised to power of minus 3 amps. So if you calculate that, this will give you 0.05 amps. So the current here is 0.05 amps. Our external resistance is 7 plus our equivalent internal resistance, which is R plus 1. So, sorry about that. So then if we process this and make R the subject of the formula, you bring this one to this side, this will be 0.5 divided by 0.05 equals to 7 plus what? R plus 1. 0.5 divided by that is 10 equals to 7 plus 1 is 8 plus R. So if you make R the subject of the formula, you'll be having 10 minus 8, which equals to 2 ohms. So the internal resistance of the first cell P equals to what? 2 ohms.